To start with the problem definition and the data collection process, as the importance of defining the problem become very crucial on selecting and gathering the information that is related to your problem. The first step here in any machine learning project is to define the problem clearly. Or let's say what business problem you are trying to solve. Are you predicting a customer churn, for example? Are you trying to classify images or forecast sales? Having a well-defined problem will guide the entire process, ensuring the machine learning model you create is focused and relevant to the problem that you're trying to solve. The next step here is the data collection and exploration. Let's agree on the quality and the quantity of data will significantly impact the performance of your machine learning model. Data collection can come from different sources like databases, APIs, real-time sensors, or any relevant data source that is relevant to your problem that you're trying to solve. Once you have the data, you will need to perform data exploration to understand the structure of your data. Also to identify any missing values and uncover the patterns. We'll go through the steps that is involved in a more depth that is involved in the data collection and exploration step on the next slide. One key important step that you have to go through here, it's called the data pre-processing part of the data collection. Data pre-processing is a crucial step in any machine learning pipeline. This includes cleaning the data from missing values, removing the outliners or duplicates, for example. Also, a key step here, it's called the feature engineering, meaning that you have to create relevant features from the existing data that you have on hand. Normalization or standardization, it's an example of scaling numerical values to uniform a range. Let's agree on something. Without a clean and well-processed data set, your model may underperform. So after you've collected your data and you have pre-processed it, you've cleaned it, you've removed all of the outliners and duplicates, and you came up with new features. The next step here is to select a model or the model selection. Choosing the right model is a critical decision. The choice of the model that you have to choose depends on the nature of your problem, whether it's classification or regression or clustering or maybe an anomaly detection, which is used sometimes in fraud detection. Algorithms like decision trees, random forests, and neural networks can be used depending on the complexity and the type of data that you have and the problem that you are trying to solve. Now, after that we have selected the problem, we'll go to the model training step. The model training step, during this phase, you split your data into training and testing sets, and sometimes a validation set, allowing the model to learn the patterns from the training data. Using techniques like cross-validation to ensure your model generalizes well on unseen data can be considered as one of the most important steps as well. After you have finished from your model training step, you move to the model evaluation. Evaluating the performance of your model is a key step here. You will use metrics like accuracy, precision, recall, F1 score. Depends on the problem that you're trying to solve. So each of the problems, for example, if it's classification, you can use, for example, AUC, ROC. as an evaluation metric. However, for a regression problem, you use the RMSE, root mean square error, to assess how your model is performing on a test set. This step ensures that your model isn't overfitting and can generalize as well on a new data. After you come up with a baseline of the evaluation metrics, now you can move to the next step, which is the model tuning. Model tuning is about fine-tuning the hyperparameters, like the learning rate of how quick your model learns, how complex your model goes through the data, depth of trees or number of neurons on a neural network. All of these steps is to improve the performance of your model. Techniques like GridSearchCV or random search are commonly used to find the optimal parameters. As we have fine-tuned our machine learning model, the next step here is the deployment model, which is considered as the final step in machine learning project. You'll integrate the trained model into a production environment where it can make real-world prediction on a new real-time data. Tools you like Flask and Fast API or cloud services like AWS SageMaker, Cloud AI, and Azure AI can use to deploy your model efficiently. Also, monitoring the model performance post the deployment. It's very important steps to ensure that your model is performing well on real time and in real world issues. A real world example here, companies like Netflix uses sophisticated machine learning model for content recommendation, while Uber uses machine learning for predicting ride times and pricing based on area and based on time. Understanding the full cycle from problem definition to deployment is a key to successfully building and deploying a machine learning solution. Let's now talk about one of the most famous project management methodologies called Agile and how to leverage Scrum framework to handle and to manage your machine learning project. Machine learning projects can be complex and iterative, and using agile frameworks like Scrum helps teams to deliver continuous value while adjusting to feedback. In this module, we'll explore how to integrate Scrum practices into machine learning projects to improve collaboration, transparency, and efficiency. What is Scrum? Scrum is an agile methodology that emphasizes iterative progress, collaboration, and transparency and flexibility. The Scrum team is organized into roles. Mainly are the product owners, Scrum Master, and the development team, including the data scientists, engineer, designers, and testers, and deployers, for example. The team works in sprints. Sprints are fixed length iteration, typically 1 to 2 weeks. Depending on the project size and complexity, sometimes it goes from 2 to 4 weeks. It comes with frequent reviews and improvements. Now, after we have understood what are Scrum, how it could be integrated, and what are the benefits that it could bring to handle a machine learning project, let's now go through the key events, main events that involve in Scrum. It starts with the sprint planning. Sprint planning is crucial in machine learning project. The team, including the data scientists, engineers, and product owners, will break down level project goals into manageable user stories. User story could be, for example, collect and clean customer data, while another might be train an initial machine learning model for fraud detection. Each of the user stories comes on a format that it has to have the task and action and the value. Next, we have the daily stand-up. Daily stand-up meeting. During the sprint, the team holds these daily stand-up meeting. It's a short 15-minute meeting where each team member answers three questions. What did you do yesterday? What will you do today? And are there any blockers or challenges that's stopping you from completing your work? In a machine learning project, challenges might be or might include issues like data inconsistency, or model overfitting, or lack of computing resources. Next, we have the sprint review. At, end, at the end of each sprint, the team holds a sprint review where they demonstrate what has been accomplished. This could be more refined model or improvements in data pre-processing or new features that enhances the model accuracy. Feedback is gathered from the stakeholders which will inform in the next sprint. Lastly, we have the sprint retrospective, where the team being given as an opportunity to reflect on the process. What went well? What challenges did we face? How can we improve our workflow for the next sprint? In a machine learning project, this could mean addressing challenges with the data acquisition, or improving model validation techniques, or optimizing computational resources, or any improvement that it could bring a value on the next sprint so the team can adapt and change based on these challenges. The key concept here is the iterative model deployment. Unlike the traditional software projects using predictive approaches called waterfall, machine learning projects often require an iterative development since it has to have uncertainty and ambiguity. In each sprint, teams may start by collecting a small batch of data to start the project. Also, they could build an initial model using the collected data. Next, they can start evaluating the data and assess the model performance. Also, they could identify an areas of improvement, which is called model refinement. Based on the feedback, they can refine the model and they collect more data or experiment with different algorithms. Let's go now through a real world example, such as Spotify uses Agile Scrum approach in their machine learning projects to deliver a personalized recommendation. They work on sprints to experiment with the new recommendation algorithms, testing models, and iterating based on the user feedback and results. This iterative, collaborative processes ensure that they can continuously improve the product. The benefits that Agile brings to the learning project and software projects, it's quick adaptation to user preferences and music trends and feedback. It also improves the collaboration between the data scientists and the product teams, ensuring that they deliver a value at each of these sprints.